Guys, it's been a while since I've had to make a video. So here we go. We're talking about 9.7 mean absolute deviation, which we abbreviate to MAD. Okay, so let's define what does that mean. Okay, it is a measure that gives the average distance. Remember, we learned average is we find the average the same way we find the mean. The average distance of each data value to the mean. Okay, so now let's talk about what are the steps to calculate. Okay, step one, we got to find the mean. So step one is to find the actual mean, which is add together, then divide by number of items. All right, then step two, find the distance of each value from the mean, which means I subtract the two. Okay, so I'm going to subtract. I'm going to do the mean minus the data value, or it's just subtract the two because you subtract so you don't have a negative number. Do not want a negative number when you subtract. When subtract. Okay, step three. This is when you now average the distances, which are the answers to the subtraction. Average the distances. All right, so now let's work some examples. Okay, first things first, we have the data set A. So we first have to find the mean. Okay, so that means I'm going to do 1 plus 3 plus 5 plus 14 plus 17. And then I'm going to divide by how many? 1, 2, 3, 4, 5. So I'm going to divide by 5. This is finding the mean. Okay, this is finding the mean. So I'm going to, yes, you get to use a calculator. 1 plus 3, and yes, you can do all of this addition at one time. So you can punch all of that right here into the calculator. Plus 5, plus 14, plus 17. And we get 40 divided by 5, which equals 8. So down here, I write that my mean is 8. So that was step one. Now we have step two. Step two is where we find the distance of each value from the mean. So that means I'm going to be doing 8 minus 1, which gives me, so now we're starting to calculate the MAD. Okay, so I do 8 minus 1, which is 7, plus 8 minus 3, which is 5. So I'm doing 8 minus 1 gave me 7. 8 minus 3 gave me 5. 8 minus 5 is giving me 3. Now I'm going to do 14 minus 8, which gives me 6. And then I'm going to do 17 minus 8, which gives me 9. You'll notice that here I flip-flopped and I did the big minus the mean. Big minus small, so I just found what the distances were. You do not have to write this all the time. I'm writing this to show you how we're getting these numbers. Okay, so if you want to write it for this one, so when you look back in your notes, you're more than welcome to. And I divide by how many, which is 5. So again, we punch all of this into the calculator at one time. 7 plus 5 plus 3 plus 6 plus 9, which gives me 30 over 5, which equals 6. So my MAD is 6. My mean absolute deviation is 6. Okay, now we're going to go through and do B and C, but we're going to go a little bit quicker. Here we go. So to figure out this, I've got 5 plus, actually, I could just write it up here if I wanted to. So I don't have to rewrite. Adding, 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 and I'm going to divide by 5. So 5 plus 6 plus 8 plus 9 plus 12, and that gives me 40 divided by 5, which means I end up with a mean of 8 again. So now I need to start the MAD, which means I've got the distance from 8. So I have 8 minus 5, which is 3, 8 minus 6, which is 2, plus 8 minus 8 is 0. It's possible to have that. 9 minus 8 is 1. 12 minus 8 is 4. So now I add all of those and divide by 5. 3 plus 2 plus 0 plus 1 plus 4. Enter. So that gives me 10 divided by 5, which equals 2. So my MAD is 2. All right, one more. Oh, it's all the same. So therefore, if I do all of this and divide by 5, that's 1, 2, 3, 4, 5. So that's 5 times 8, which is 40 divided by 5. And you should also know if they're all the same, then that means the mean is going to be 8. So therefore, when I find the distance between them, 8 minus 8 is 0, plus 0, plus 0, plus 0, plus 0, all divided by 5, which gives me 0 divided by 5, which is 0. So my mean absolute deviation, which means there's no deviation in the data, it's 0. So now let's talk about if we're interpreting. What does that number mean? All right. Interpreting the data. Okay, so we're going to write a little description. The closer MAD, M-A-D, is to 0, the less variation there is in the data, which means the numbers are closer together. Numbers are closer together. Okay, there's not much variation. They're all centralized close. See how it went to 2 here, and all of these numbers are really closer together. We've got a lot more spread out here in data A. Okay. Period. Data values are clustered around the mean. That means they're closer to the mean. Okay. How do outliers affect the mean absolute deviation? Okay, so let's talk about that. If there's an outlier, that means there's a larger variation. So therefore, they raise the math. They raise it. They're going to make it higher because the difference between the numbers is higher. All right, let's work an example of what it's probably going to really look like when you have your problems. All right, number one. Find the mean absolute deviation of each data set. Round answers to the nearest tenth when we're doing this, if necessary. Okay, so the first thing I got to do is find the mean. So I'm going to add all of these together. And yes, you can do exactly what I'm doing here to show the work. 2, 3, 4, 5, 6. So I'm dividing by 6. So in the calculator, I have to do 71 plus 78 plus 75 plus 74 plus 80 plus 72. Enter. So that gives me 450 divided by 6. 6, which gives me 75. So 75 is the mean. So now I've got to find the mad. Okay, so to do that, that means I'm doing, okay, 75 minus 71, that's 4, plus 78 minus 75 is 3. Notice I'm not having any negative numbers. I'm just doing what it takes to find the difference between the two, the distance between the two. 75 minus 75, that's 0, because that's the exact same thing. 75 minus 74 is 1. 80 minus 75 is 5. 75 minus 72 is 3. Add them all together and divide by 6. So we have 4 plus 3 plus 0 plus 1 plus 5 plus 3. Enter, and that gives me 16 divided by 6, which equals 2.6 repeating. Now, it says to round to the nearest tenth. So that means my answer is going to be 2.7. Okay, moving right along, let's look at number 9. Okay, when we think about, it says, which is a better measure of variation of data? Better measure for the variation of data, range or mean absolute deviation, and we have to explain. Okay, well, range, remember range, that's just the big minus the small, correct? So that just gives me the spread all the way. It's just the big minus the small. So therefore, the better measure is actually the MAD because it takes into consideration all data points. All right, so here we go. Let's write that information down. Okay, so MAD is better because it takes all values and their distances from mean into account. Range only uses highest and lowest values. Not looking at others or how they are clustered, like if they're close together or far apart from the mean. It only looks at the highest and lowest. So you've got to make sure that you can think about how are these different measures of variation compared. Okay, you got to finish the notes and the homework. You'll have a great day.